I was telling Elias, we actually had a PhD mathematician as part of our staff, and he was
I told you to keep that quiet about me.
That's the funniest thing you've ever said. Welcome to the Decode podcast. As you can see, I'm in a little bit of a different scenery today. I'm joined with Miles Moreau here at Kick in their headquarters here in Rancho Bernardo, San Diego County. We bumped into Miles all over the trade shows and had the pleasure of interviewing him a couple times. And every time I see him, he's like, "You got to come up and see us. You got to come up and see us." I'm literally like 15 minutes away. I'm like, you know what? I'm going to come up there. So here I am. Thanks for having me, and thanks for joining us.
You're welcome. Thank you.
We got Mr. Daniel Stanfill and the Sean Kincaid. It looks like you got a haircut. Looking good, Bubba.
Yeah, it looks fresh.
You guys being obviously not here in San Diego, you didn't have the benefit of getting the tour of Kick here, but it was really cool to see kind of all the inner workings of how these things were made and learn a little bit more about them. I think one thing that jumped out to me was the heat shield that's on your profilers, and kind of looks like some kind of dense fabric or something that would be wrapped around an exhaust pipe or something. But Miles was telling me before we came on that it does such a good job of cooling down the unit when it comes out of the reflow oven that you can almost just pick it up with your bare hands, ungloved, as soon as it comes out of the cooling zone. But that was pretty cool. But yeah, thanks for giving me the tour, and you guys missed out, but I'll send you some pics.
I mean, I use his devices, so I know the shield you're talking about. Is he talking about the fuzzy orange?
What is that, like camel stuff?
Yeah.
Camel hair, orange stuff, whatever that is.
I can tell you what, though, doing profiling, and this might be a product suggestion, Miles.
That's what he came here for.
That's what he literally was like, listen, I'd like to talk, and talk about reflow and everything, but Sean, really, this is for you and to tell me what's going on with my life. I don't know, Daniel, if you have experiences, but
yep.
Let's say you're doing a profile, right? And then it comes out, and then sometimes you got to wait for that controller to get to a certain temperature before you can get it back in.
Right.
Like that time feels like
waiting for it to get back to the ambient temperature.
It's not long, but like it just feels forever while you're in that moment.
Mm-hmm. If you're trying to do multiple profiles in a row and get it like dialed in,
it's usually when I didn't attach some thermocouple correctly, right? And then I'm watching it like and then so I gotta wait for this thing to cool, and then I gotta and then I just put the tape on and let's go to it. So it's always from there. But yeah, Miles, I mean, we had a pretty interesting conversation before everything we even kicked off here about, your business and how far back you guys gone and your products and how they last and stuff like that. I'm always fascinated because I think I always know the full like Kick lineup and everything like that. But like my local rep, Don Ernst, came by, and he was telling me about this pallet type of thing that you can put through the reflow. And I didn't get to pick his brain too much, and I know we talked a little bit about it, but it's almost like your embedded sensor system, but on a standalone unit that you can just put through your conveyor without having to do the entire embedded system. Do I have that correct?
Yeah, in a way, yeah, that's correct.
You can tell him if he's wrong too.
Oh, that's pretty good. It allows you to get that picture, or more like a video of here's what's happening to the oven, right? The profiler tells you what's happened to the board, but here's what's happening at board level in your oven, zone by zone. So it is kind of the next step if you're looking at different levels of what can you do as far as metrology or knowing what's happening with the process. There's these different tools or solutions. A profiler is one. that has a lot of uses as far as NPI or validation or optimization. Then that's what our SRA, our palette with embedded sensors, gives you that view of the oven that where the board's going through.
How much more evolved is that than the leading thermocouple that you put out an inch in front of the board to keep track of the ambient temperature in the oven compared to the delta on your board?
Well, this one's more, like I said, it's more oven related. So that helps with kind of some of the triggering with the RTC and offsetting where the zones are and where the TC's in relation to the front of the board. Then the fixture, it does that kind of across the whole product path. So we have three holes across. So you're characterizing the zone, right? Each zone as the fixture goes through. What's the ambient temperature? And then it's the data analysis. That's one thing you brought up, Sean, is how do you keep selling profilers? At a certain point, there's no more companies making boards, and they already have your profiler.
Yeah.
So it's then what you do with the data, right? So now we look at, okay, with this fixture, okay, what do you do with that data? Well, if you can know what's happening at the oven path, the three characteristics we focus on are the ambient temperature, the heat transfer, and then the speed, the rate that the oven's conveying the board through. Then you can do a kind of a twofold. And I actually just did a recent post on LinkedIn. I try to do these little practical tips as far as if you just run the profile, that's great. You know that your board has the right and the recipe is correct for that board. But then do you know the machine's repeatable? Because that means the board that profile board was correct. But is your oven going to do that for the next, day, 2 days, next week? And that's where fixture comes in is, okay, I need to validate that too, to say my machine is working properly.
You bring up a really good point. The speed of the conveyance is a critical element of it. And most of the time, I guess so much thought is going into the temperature profile. And speed's incorporated into that. But if you're not actually calibrating or auditing the oven, Sean, do you ever do that? Do you ever put a board in and just time it and see if it goes through the oven in the appropriate amount of time?
You know what's really sad about that? The same rep. This is like the Donner.
Oh boy, here we go.
He came in and it was on my old 2004 or 2006 nitrogen oven I was using. Mm-hmm. Thank God at the time I had already bought the new 125 inch, right? So we were really running production on it. But the mesh belt, Don noticed that the chain was going like this. Mm-hmm. And it was actually bouncing because the wheel was off. He was like, if I was coming in here as a customer, I would fail you on your audit because of this. And exactly that, right? Like, Miles, I have no clue. We just click run profile on the oven sometimes. You know what I'm saying? Like, we don't ever check to stopwatch and stuff like that. That would help out big time. The one thing I always want to do is like a quick tip that I think it'll help out with, like a little quick video we could do for people on here that we can talk about. This is like a hot debate, in my opinion, because
that kind of fits with
pun intended.
It does, right? So I have heard from 400.
You came up with that, but
yeah, people have. Well, I like to be ad hoc sometimes, but people say use Kapton tape only. Some people say use aluminum and then the Kapton over that. Some people say just use aluminum. Some people say use the stuff from O'Reilly Auto Parts, and then some people say use the high temperature solder. And I know you did a fantastic paper on this at the SMTA a while back ago, but I just want to hear what's your opinion on it and why for attaching the thermocouple.
Well, the focus on the paper, as we started, we're like, okay, should we do it, set this up and say, okay, it's a competition, right? What's the best one? But as we kind of set up the design of experiment and everything, we're like, well, actually, it's more what's the best one for the situation you're in, because they all have benefits and shortcomings. So the paper kind of never, I mean, it does come towards kind of a better method, but there's like an if to it, because the big if is your customer going to supply a profile board? That's the question first. And a lot of the times the answer is no. Right. So
you just can throw out all the destructive methods, right?
Right.
Those
so
are gone.
You throw out then you're some type of adhesive or tape. And then you're like, okay, from the tapes, what's the advantage? Well, Kapton's cheap and pretty well available on the manufacturing floor. People use it for all sorts of stuff, and it's been used a long time. But over and this is something even, I talk with our competitors because we know each other, and they give the same advice. You can use Kapton for to hold the wires down, or if you're using aluminum tape to help it keep the edges down, or window
just
painting.
Not contacting the thermocouple part, right?
Because it very easily bubbles and lifts around the bead, so you get a little pocket of air that you're measuring along with whatever you're trying to measure. You have to reattach or push it down after each run. So effectively, if you're talking about a design of experiment, which every profile you run is, you're changing it because you're having to reattach or reposition slightly. Mm-hmm. So Kapton typically, even though in the paper it can get repeatable results, the can is if every time you make sure there's no bubbles, you kind of push them out and have to do all this stuff. The aluminum tape we found, as far as a tape solution, gives you much more malleable, holds in place. The heat transfer or the conductivity of the tape is better than Kapton. Kapton deflects stuff more. But then you get to the destructive methods, which some companies, if they're running the same board a lot and want to validate that profile, maybe on a weekly or monthly, then they might set up a board, leave the thermocouples attached, and have a dedicated board that's populated. Then we looked at high temp solder for epoxies. The high temp solder was probably, if you look like years ago, decades ago, was kind of the standard. But it requires somebody is good at hand soldering, and if you don't get that right, then the TC bead is sitting in a big glob of solder, not on a solder pad. If you put too much solder down, you're adding mass to the place you're trying to measure. So the epoxy kind of, but it's if you do get it right, the high temp solder makes a strong connection. If you get the bead down on the pad or wherever you're trying to measure, it's not going to move. So there is the plus sides of that. The epoxy just was it got rid of some of those downside of the high temp solder. The epoxy we use, though, does take a UV cure. So then you have to have that around on the floor, or get something like a little UV wand where you can do that. But
and how removable is it?
Those are more permanent. You could with the epoxy, use a solvent and kind of reuse the thermocouples over time. But the whole idea is you're trying to make that as permanent as possible, so that the next time you do a sample, nothing's changed.
Yeah.
Isn't that so often the case, though, in our world, with whether it's reflow, measuring reflow with what techniques to attach a thermocouple, or what aperture design to use, or what paste to use, or there's all these factors, and there's never just a universal this is the best thing, right? It's always
it depends. It depends every
time. Should be
time.
the name of our podcast, to be honest with you. It depends.
kind of going off that same like one size doesn't fit all type deal. When we were on the floor earlier, you were telling me, well, I saw a bunch of digital scales, and I'm like, what's up with all these scales? And so you started to explain to me how you can kind of take the dimensions and the weight of the board and use that and plug it in some way to kind of get like an approximate starting place for a profile and kind of shorten the time required or how many tries you have to get. Can you explain to these guys a little bit? I mean, I totally understood it all the first time, but they haven't heard it. So,
yeah. And this goes back to what you talked about, Sean, is like, how do you keep selling profilers, right? Or if you stop selling profilers, or the customer has them for 7 or 8 years, what else can you provide them and make a living? And that's in these tools, just like the thermocouples. It's kind of nerdy in a way. It's like, why do you look into this stuff so much? It's like, well, that's what we do, right? Well, that's what we're curious about. So if you're going to be curious about that, okay, so then look from the customer. Is like, nobody wants to profile. So how can we give them tools that make it easier and also match with it depends, I'm this type of manufacturer, or I do things this way, or I'm building for these types of customers. Then you can't just have a standard profiler gives you the results. That's just going to get you a profile, right? But your needs may be more than just a profile. If you're, in this case, we're talking about NPI. So if you're running short runs and you're trying to get new customers all the time, you have new boards coming in every week, you don't want to have to spend half a day setting up a recipe on the oven. So what we developed and what we looked into is, okay, one of our core technologies is our prediction model. It's very accurate. And then we built on top of that, and this is kind of the nerdy aspect of it. I was telling Elias, we actually had a PhD mathematician as part of our staff, and he was
I told you to keep that quiet about me.
That's the funniest thing you've ever said.
He was the brother of our one of our software engineers. This is like probably 3 decades ago, and he had no experience in electronics manufacturing or soldering or anything, but knew math. And so we were able to look at, well, if we could look at more recipes, use our prediction, and look at every possibility, then there's a lot of recipes on the oven. So when you say which is better, well, it used to be you go to a customer and the set points would be in 5-degree increments. If you guys recall that, and some people still set that for some reason. They'll say, okay, first zone's 120, then I'll do 130, and then I'll do 165.
I think I started like that, to be honest with you.
With the oven, it goes degree by degree. So why are you ignoring those in between temperatures? Because that could actually help you dial in a better process. So if we're able to look through those recipes and then correlate it to length, width, and weight, then when you come with a new product, you have all these profiles you ran over the last year. So Sean, how many profiles on new products would you say over a year's time if you just had to spitball it?
I don't want to think about it. I really don't. Let's just say 38. We'll go with 38.
38?
Yeah,
so
at least.
If you had 38 different boards from all these different customers, and you had profiles on them with length, width, and weight, and then you come with the new board, and instead of you doing it, you said, I'm going to have somebody else do this. Somebody who just started as a technician, doesn't know reflow that well. They put in length, width, and weight, and this will give them a starting recipe. So they don't have to have, I remember running this type of board, and it'll have these type, and I need to tweak this to get the peak here, whatever. That knowledge is now in the software.
Yeah, you actually got me in trouble because of that at work about a couple months ago. My dad came back from Florida and he gets on this cleaning kick and he just moves everything cleaning around. He comes in my office and he goes, "What the hell is this?" And it's a scale. It was like, "Dad, it came with the kick profiler. Like, this is it, so we can weigh the circuit boards." He's like, "Okay, sure." It's like
a side hustle.
Yeah, right. Like I'm a retired criminal, Dad. I'm not doing it. I'm weighing circuit boards now, right?
That may or may not be what I said to Miles when I saw the stack of scales.
I don't know.
But you were saying that methodology, well, like the average, that cuts the average amount of like passes to profile down to like 1.6 or something like that.
Well, it's built for your oven too, right?
On our
so that's
old
the beauty
ones,
of it.
on our software, we have to enter in also, like, we have to tell it what kind of paste we're using and whether we're looking for a straight ramp to peak or a ramp soak spike profile, and then also the length, width, and weight of it, and then it spits out the profile. Do you still have to give those data points also, or no?
You select your process window. The nice thing about the way the search engine works and the model works is you can have even the profiles that didn't end up in spec, right? So say you ran one of your first boards and it took you 3 passes. The first 2 were out of spec. Well, the recipe information related to that, you now have a new board, maybe it has a different process window. You switch pace. So the data relationship of that recipe to that board, length, width, and weight, regardless of the process window, might be useful for this new board. And then it uses that information. You apply your new pace spec to that data, and it says it'll use that as part of its intelligence.
So there's no such thing as a wasted profile.
Right. All data is good.
Yeah.
You look at data now, right? They want to look as much data as possible because it may have not applied well for that particular board and that paste, but that length, width, and weight of board and that settings on the oven gives a relationship that might be useful for this new board that you have. So,
Daniel, I got a process question for you. I'm curious about, because Jerome kind of blew my mind the last time he was here. We were doing a profile together on a board, and we ran it through. And he wanted to keep that board hooked up with the thermocouples because he said, really, the way you should be testing this is actually during production. So have your oven full and run your profile. I've never done that, but he said that's because you have. I don't know if because Miles,
it changes the thermal, like how much mass is going in the oven at one time, and the circulation and the.
But I've never done that.
Transfer the load in each zone and everything. I mean, it makes sense.
Partial loading is the ideal situation to. I mean, you can't always do that because you don't, especially if you're doing short runs. Yeah. You don't have the boards ready to do that. Now,
see, that's what's nice is there's no judgment from you, Miles. As contract manufacturers, sometimes we tell you the shortcuts that we feel like we are pushed into a corner and have to take sometimes. And you're like, it's okay. Everyone has to make ends meet,
Well,
this is the right way, but
there's the ideal way, but I don't think I've run into a factory where I've walked in and they're doing everything ideal.
Yeah.
Ever, right?
Maybe if you were building one thing and the same thing always over and over, right? But
yeah,
the life of a CM.
But even especially with our monitoring systems, the programming for those. So you talked about the embedded sensors. Your programming for that is running that NPI profile. When you get it in spec, that's how you're programming it. The ideal to set up that baseline is have a partial load in there because the embedded sensors will now have the characteristics of an oven trying to control while there's constant mass going through each zone.
That almost requires, depending on the length and width of the board, right? Like now I need to have like 4 to 8 different destructive boards populated, right? You know what I'm saying? Just as like, hey, you're my dummy sacrifice lamb, because I want to see how all of your components and the board is affecting it. And in reality, we should, right? But it's just not, no one's going to pay for that.
And then it's kind of some of the small things that we tweak in our software. Like I keep going back to this. That's where a lot of the value add is. A lot of times you're running a bare board for your profile board.
Mm-hmm.
Yeah.
So you can't, the first guess, the autofocus is our product where it gives you the first guess recipe. That helps so that you're close to getting to that first pass, and because you don't have materials to waste.
Right.
But the other thing is you can manipulate in our software. We set up tools just around the process window. So you can set the spec and you can target, say your paste spec is 235 to 245. So when you're optimizing, setting the recipe, it's going to be 240, right? That's the middle of it. But you're like, well, this isn't a populated board. So when this is populated, that's going to be probably more mass. There's going to be paste. There's going to
It'll be less. So you want a higher temperature on a bare board to compensate?
The same, but I'm going to set my target for the prediction to be 242 or 243. And then when it's optimizing the recipe, it's going to target a little bit higher, same limits, but I'm going to position it here with the bare board. So then when I run production, I know it'll be dialed in.
You're anticipating that
right.
Thermal.
So you can actually, and that's where these tools come into play, where the customer finds more value. So they'll come back to Kick and say, yeah, I got your profiler. I'm going to keep it for 8 years. But I see you have these new features that help me even, do things even better. Right.
Yeah. But Miles, we talked about the price of your calibrations, and you're not going to retire off of that. And your software that you're talking about, the tools are free. It comes with it.
Some of them are free. Some of them are options that you have to pay for.
Yeah. Would you buy the equipment? Probably, right? But other than that,
Sean's really concerned about the business model.
I'm felt that you're so worried about me, Sean.
50 years.
It's a good product.
You're going to be working forever trying to solve this problem.
Well, it's a success story, if you ask me, right? Like it's a product that lasts a very long time, especially upon a frequency of use. You know what I'm saying? If I'm only turning this thing on 40 times a year, you know what I'm saying? It's gonna last a while, right? And on top of that, I have one. Why I don't need two unless I'm hooking, like you said. We ran these scenarios where we have the one that's dedicated for a board, right? So, but I mean, how often does that happen? I don't know. It's just.
Well, that's where the what we call our like ecosystem of solutions, right? So a lot of times when I'm going to a customer and saying, okay, a lot of it's okay, what are you doing first? Because I want to know what part of our solutions, we have customers who are like, okay, our lines are dedicated to this big company OEM, and they ship 20 million of these products a year, and we're their main contract manufacturer, and we have 8 lines dedicated to their product. And this, so then when I hear that, and they're okay, they're trying to be efficient. They're not running new setups, new recipes, and needing to re-optimize and stuff. So what's the solution that we can provide them? It's not going to be a lot of these efficient NPI tools and stuff like that. But then we have, like in our prediction model, it's going to search for recipes with faster conveyor speed. So now you can set the conveyor speed. And then when they're running production, well, I need to be running production all the time, not verifying the profile. If I have to every morning or even once a week and spend 20 minutes for 8 lines, that's X hours of production time. I'm not producing those boards.
Wow.
So then
real money.
So then I say, well, why don't you embed this system and collect the profile automatically? Because you're not, and then, okay, crunch the numbers. well, that's pretty quickly. That's uptime producing boards where I'm making money. That's worth it. And so, yeah, I have to get 8 of them, 1 per oven. But the return on that is, every morning that I'm supposed to be running a profile for my customer, it's doing it automatically now.
You were mentioning something to the effect of like, it can be so granular that like, if your objective is like, okay, I think you mentioned like in the European Union, like they have mandates for how much energy they're using. So, okay, here's a profile that works, but how can we take this to a profile that uses less energy, right? Is more energy efficient.
Are you serious? They're monitoring that over there? How does anybody get anything done with the regulations they got? It's unbelievable. Hey, manufacture a circuit board in a 480 volt.
Their energy costs, right? Especially over the last few years. And if they could say, and we did a paper on this, we had a big contract manufacturer who monitored the power to the oven for a month on the recipes they had for, and we said, okay, what products are you going to run on that line? And then we re-optimized the profiles based on our search algorithm for reducing energy consumption, basically bringing down the temperature, and they can moderate what the conveyor speed or their cycle time is. And they between 9 and 12% savings in energy.
That's double digits.
When you have 15 lines.
The crazy part too is there's a 3-point option on the software, and you just click one button and it did that. You know what I'm saying?
Yeah.
That's the wild part, right? That guy, math guy. I know we're not going to act like it was me, but that guy was really smart.
Claude, it's Kick. Right?
Yeah.
Too funny.
I love talking to people from the EU though, because you can relate to this being a local Southern California guy. Like, there's nobody in the country that we can talk to about gas prices that understand, right? Like, I was in Michigan not too long ago, and they're complaining about like $4 a gallon. And like, you wouldn't be able to get into a gas station if there was $4 gas here. Everybody would be filling up, trash bags full and everything. You talk to somebody in the EU and they're paying like €6 for that much gas. So it's like, okay, I feel better.
Yeah, but in Europe, their travel distance is shorter. So,
well, their cars are, they use a lot of diesel out there, and they get really good fuel economy.
Why did you say diesel like that?
How would you like me to say it?
Say it again.
Diesel.
How do you say it, Daniel?
Diesel.
Miles.
Diesel.
Vin Diesel.
Diesel. I'm sorry for being ad hoc, guys. It's the 80s.
Did you learn a new word?
I did learn a new word.
It's your biggest tell when you try to force it in multiple times. It's like, oh, you learned something new.
I promised this guy I'd get him into the episode. So
we were talking about that's sometimes ignored, which we're coming out with probably around the same time as this podcast, is the fan speed. So that can be manipulated as well, and that has some value, both oddly enough in energy savings, because the fan motors are also a hog, but also in manipulating your recipe without changing the temperature. So if you do want to try to get recipes where you don't have to wait for 30 minutes while it controls to the new setting, you change the fan or the conveyor speed, and that's relatively instantaneous. That's another way of optimizing your profile and your recipe, utilizing what the oven's capable of.
It's interesting you say that. I had a board where I had these tall potentiometers, and I realized that the reason they were swimming all over in the reflow, but nothing else was. And after a while, I figured out that it was because they were too tall. They were acting like a sail and getting blown around when it was liquidous. And so I just lowered the blower a little bit, but everyone on LinkedIn acted like I'd committed some cardinal sin, and I was going to cause a huge thermal imbalance or problem, like massive change to the profile.
Well, that's kind of the way our model works, because we're looking at use cases, right? It's driven by your situation, right? Not just let's do this for the sake of doing it, but all right, can I have a recipe, dial it in? Now I want to reduce my fans, so I'm going to tell the system to reduce the fans. Now, what temperature settings do I need to achieve the same result?
Yeah.
Right.
When is this coming out? Because my PE
vice versa is, I want to keep the same settings on these different products. How do I manipulate the fans to have different fan speeds? And now my changeover time has been reduced.
My PE taught me probably about 4 years ago, fan speed is the most underlooked and undervalued part of an oven. And the fact that you guys are coming out, so is this going to work with your embedded system, or is this going to work with the profiler?
It's with the profiler.
Really?
But
when does this come out?
He's so worried about your business earlier, and now he's trying to buy something.
Yeah, well, no, that's fine. you can buy it from us, Sean. I'll be happy to sell.
When does this come out?
It should come out in July.
Oh, this is going to be awesome. I'm going to have so much fun. Yeah, because I don't know. I run my fan speed a lot lower than what most people run it, except on the cooling. But, there's so many times where he's just taught me throughout the years, check your fan speed on this, check your fan speed on this. Even drying out flux too soon. Yeah. Right? Like people don't realize that that happens a lot. And if I don't know, I guess if you just, because when I was first ran, I didn't know what I was doing.
The roads dry out a lot faster when it's windy,
Look at that. That should be a t-shirt or something. That's beautiful. So I don't know. That's cool. I'm excited about that. That's going to be awesome.
And that's So you look across all and this is just on the profiling side. We've been talking about, besides that profiler, there's all these tools that can be an advantage, and not every tool is going to be right or the solution for every customer. But we keep on seeing these different use cases or these different situations that customers get into. It's like, okay, can we solve that? Oh, here's a way of looking at it that nobody's really looked at before.
And on top of that, like, how do you know the effectiveness without being able to monitor the data and have data results, And this will be able to give you a window into that, which would before you just didn't have.
Yep.
What's the name of that new feature software that's coming out?
That's a good question.
Kincaid?
Ad hoc.
The Kincaid factor.
Ad hoc. Yeah, ad hoc.
The Kick-Aid. You just take the in out.
It's mainly just fact prediction. Yeah. We will have some marketing term added in there.
That's cool, man.
We're
I like hearing that you guys are still progressing, you know what I'm saying? And still growing and stuff like that. Cause it'd be easy to put up the sails and ride the thing into the sunset, but you're still going at it.
It sounds like the sails aren't high enough for you for that. You think you can ride off into the sunset. I still can't figure out which side of the coin you're on here.
Well, listen, so before the show started, I was talking about like dishwashers these days. You buy a new one, they people last like a 5-year dishwasher. You're like, okay, that's time to get a new one because it broke. Same with refrigerators, right? Like we all know the brand that was dying within a year, and the ice makers that were going. You know what I'm saying? So, the Kick Profiler though, it lasts for a really long time. I told them, like
harsh environment too.
Yeah, I'm like, maybe try the new model of, it only lasts 6-20 years, So.
That keeps us kind of on our toes. It's like, how else can we help? What else can we do? Because if you just have a data logger, then there's not like a large progression for innovation there. Just, okay, you can only do so much as far as data logging when you're looking at specific applications. So then, okay, then it's like, okay, we can do a really good job of collecting the data. Now, what can we do with that data? Is there other data we need, different sensor types? Can we embed the sensors? And then once we embed it, now how can that data, then you start to look, okay, can we be part of the solution at the factory level? Right now, if you have data from your reflow process, either via the profiler, the fixture, getting oven data, or the embedded system, then how does that relate to, even we were talking, you're further up the line, right, with the stencils, okay, what's the relationship between the stencil and the printing, and then the placement, and then the reflow, and then it comes to AOI or test and something happens. Okay, how are you relating that? And it's all in the data. It's not, okay, what is this data logger doing? It's, okay, what is the interpretation of that data in the reflow process? How does that relate to what happened when the board with the paste was printed? So
you could get
an opportunity to cover. Now we're not just, okay, we got to sell one of these profilers. That's only, now we can say, oh, hey, we offer value all the way up.
You could get extremely predictive too with your results if you were able to see what the SPI printed, see how it looked with that profile as it went through the oven, and then also how it looked at AOI. You could get really because I would assume, as long as like environmental factors stayed the same and people turned the exhaust fans on the oven when they were supposed to run the machine, that profile would stay the same consistently, and that solder joint would react the same way on that board every single same time, That would be pretty cool to see. And then you could see as an adjustment, like with Daniel's, would you say it was a potentiometer that acted as a sail? Yeah. Then you could see how that change made from the blower setting, right? And nothing was changed to the paste, just to the reflow oven.
And then that's where you add value of the, instead of the spot check, if you're checking every board, then you can start to see the trends and how that's changing over time.
Miles, one of the things we talked about, I think it was at SMTAI, I brought up the idea of, since I'm often stuck in the position of only being able to use a bare board to profile, the idea of comparing the results with weighing a populated board and then entering in that information into the profiler and doing it again. Have you explored that at all with anyone yet, or know of that?
Yeah, we have done a little bit of manual manipulation around that. And that's something that, that has the possibility to automate, where you can kind of,
if you know the weight of all the components, and maybe even if you want to get super granular, if you know the foil thickness on the stencil and the anticipated volume of paste, I mean, you might be able to get like extremely predictive if you get to that level, right?
Imagine if you could create a tool that would take the BOM and then calculate the total weight of the components. The solder paste weight you can get for sure. How much of that goes away during reflow? I guess you could calculate out the percentage of solids, right? Yeah, you might be onto a tool here, Bubba. Sean, I see the gears turning.
Bubba.
We've looked at ways to do that. For that, one of the use case of, you only have a bare board, and then can the model adjust accordingly based on electronic data, right? You have the BOM, the stencil, the paste, all of that. And I think in the future that'll be more accessible. But right now, and we had this discussion, is, okay, what's the value add and what's the return on the investment? So in order to have, say, from Mentor, you have their component library and everything, and you could then, okay, is the customer going to have a subscription license that the Kick software can use along with all this other information? And then how much is that going to cost? And then we look at what we do have now is a scale and a measuring tape, and you get length, width, and weight. And we're like, well, 1.6 passes is pretty close.
How much time, resources, and money do you want to throw at 0.6?
Yeah. So then it's a matter of what's the difference between the weight of the bare board and a populated one, and how far off are you? And that's where, like right now, manually, we can kind of manipulate where your target is in the process window to kind of say, I know this is going to happen. I'm going to have this more mass here. So I'm going to anticipate that and set up my process window. I'm still in spec, but I'm going to target it in certain position within that window. So when it's a populated board, I'm dialed in. So it's
how much is the industry moving at both extremes, affecting like what you guys are researching? Because I mean, it's easy to understand how all the components getting massive. You have these BGAs and microcontrollers that are getting to be like 300 millimeters square big, but that's easy to understand what kind of impact that would have on the thermal cycle. But what about when you have a board that's loaded with thousands of extremely small passives? Is that where I guess maybe the fan speed and all that comes into play, understanding all that stuff more intelligently?
Yeah, a little bit more. And then also it's less the 1,000 passives you have on the board. It's the layers underneath that are going to throw off, where you might get tombstoning or something, because this one's right on the edge of where you have a bunch of color or something. Yeah. And then all of a sudden you're getting these defects, and like, why is that? Maybe if I just switch the direction of the board, then that changes everything. And that's your solution. So it goes back to that. What do we say? It depends.
That's why you should put rails on all four sides of the board.
Yeah.
Tell you the amount of times where I've told somebody, well, you change the direction. I can't. I only have rails on two sides of the board.
It's a good thing you saved those 7 cents.
Yeah. Well, a lot was covered here tonight. If people want to get a little bit more information on what's kicking off here, how can they find you? What's the best way to I've been saving that up all night. How can they get a hold of you?
Kickthermal.com. That's our website.
Producer Paul will flash it across the screen.
YouTube channel is Kick Thermal. A lot of good tutorials and how-tos on there as well, on stuff we talked about, TC attachment, setting up process windows. So I mean, that's another part of our value when you get the Kick Profiler. You guys both use the Kick Profilers. Is we like to pride ourselves in being kind of part of your process team, because we have kind of a certain expertise, and our customers appreciate that, so they can call it. And hey, it's not just how do you turn this thing on, or how do I click through the software. It's okay, I'm trying to set up this board. How do I use your tool actually to achieve a good profile? So,
and Miles is a good follow on LinkedIn too, because he's always doing
you mentioned LinkedIn in your post. You had the one that got like 150 or something reactions the other day.
I seen that the other day.
Yeah, he had one blow up.
I was pretty happy. That was one. I don't know. You never know what's gonna capture somebody's attention, but all of a sudden that one popped. I was like, interesting, because I've been doing that, trying to do more just on kind of, here's some good practical advice for profiling or the soldering process. And that one just clicked with people. So worldwide, I mean, I was like, all of a sudden I get a bunch here. So somebody liked it, and everybody else who was following them, like, hey, yeah, that is
And then the next one you do gets like 5 likes, and you work for hours on it, right? And then you see Sean post something about getting a haircut, and he gets 3,000 likes. But
it's nice hair.
I appreciate you having me here and showing me around, and we appreciate you being with us. And I also wanted to mention for our viewers and listeners, Daniel and I will be at PCB West. PCB West is kicking off.
Are you guys really going?
We are. Not only are we going, but we are going to be both speaking, Daniel multiple times, in the inaugural assembly track. So this is the first time that
whoa, you're supposed to approve this. You know what happened to PCB East.
Come on.
Are you sure you want to go down this route?
September 29th through October 2nd in Santa Clara. You can come and meet the talent of the Decode podcast.
Those account. The ones that have more than just their hair to offer.
Nothing will be ad hoc there, though, so don't expect any surprises.
All planned.
Yeah.
But as usual, thank you for tuning in. If you like and enjoy what we do, please do give us a like or subscribe. It sounds cheesy, but it helps us get the message out there. So thank you for tuning in, and we'll catch you on the next episode of the Decode podcast.